Under orthogonal cutting condition, a turning operation is carried out on a metallic workpiece at a cutting speed of 4 meters per second. The orthogonal rake angle of the cutting tool is 5 degrees. The uncut chip thickness and width of cut are 0.2 mm and 3 mm respectively. In this turning operation, the resulting friction angle and shear angle are 45 degrees and 25 degrees respectively. If the dynamic yield strength of the workpiece material under this cutting condition is 1000 megapascals, then the cutting force is. So we need to find the cutting force in newtons and we need to round it off to one decimal place. Let's look at the solution. From the question, it is clear that the rake angle of the cutting tool alpha is 5 degrees. The uncut chip thickness T is given as 0.2 mm. Width of the cut B is equal to 3 mm. Friction angle is given as beta is equal to 45 degrees. Shear angle phi is given as 25 degrees. And the yield strength of the workpiece tau s is given as 1000 megapascals. Then the shear force experienced will be calculated as Fs is equal to tau s into Bt by sin phi, and substituting tau s as 1000, B as 3, T is equal to 0.2 and 5 as 25, we get the shear force experienced as 1419.72 newtons. From the merchant circle diagram shown, we know that the shear force can be written as R into cos phi plus beta minus alpha, and the cutting force Fc can be written as R cos beta minus alpha. Taking the ratio of shear force to cutting force, we get R cos phi plus beta minus alpha by R cos beta minus alpha. Substituting all the corresponding angles and simplifying, we get the ratio of shear force to cutting force as 0.55. Then this gives that the cutting force is written as shear force divided by 0.55, and substituting the value of shear force obtained above and simplifying, we get the cutting force as 2573.40 newtons. The accepted answer range for this question is 2570 to 2576.